My name is Billy Hoffman. I'm the lead R&D engineer at SPY Dynamics. I work for SPY Labs. Today we're going to be talking about security issues with AJAX. There's a lot of them. You know, Web 2.0 is very popular. Everyone's like AJAX, buzzword, e-commerce, it's all this fun stuff. We're going to actually talk about what the security of all this is. You know, I love my responsive Google Maps as much as the next guy, but let's see what the security issues are involved with deploying AJAX-enabled applications. Let's see what we can do to try to fix them and what we can do to try to mitigate these risks in the future. So we're going to run through real quick the architecture of traditional web application. Touch briefly just on what is AJAX and why does it help? Why is there a need for technology like this, or a suite of technologies really? We're going to talk about 4 huge security issues with AJAX and just AJAX applications in general. This is mainly just all the nasty stuff you can do with cross-site scripting. And finally, guidelines for writing really, really secure AJAX apps. I'm also giving a talk at 4:45 called Web Application Worms and Viruses. We're going to talk briefly here about like the MySpace worm and the Yammer worm that hit Yahoo, because those were notable examples of AJAX worms. We're going to go into much greater detail this afternoon, so I encourage you, if you like what you see here, to come on back. Okay, so architecture of web applications. So yeah, these things are pretty basic. Essentially, the browser receives some type of input from the user. You know, I click on a link. Let's say I'm filling out a form. We have this JavaScript logic layer in there. It performs simple logic validation, input validation. The whole reason this thing originally existed is to try to make web pages more dynamic, and also crossing that internet cloud is expensive. You know, on the order of, depending on your bandwidth and your connection speed, you're talking half a second to 2 or 3 seconds, depending on how much data is coming back. On the server side, you've got some type of back-end business logic. You've got some ASP or some PHP, some JSP, something like that, which actually takes the input you submitted and says, oh, okay, they're signing up for an email letter. Let me get the username, or let me get the email address they gave me. Let me get the, their interests, all of those things, insert them into some back-end process. Like I said, talks to possibly some other types of tier, in this case a database. They're normally back-end processes filling this database. So a great example is Google. I mean, obviously when you do a Google search, it doesn't spawn a crawler to go find this stuff. They've got crawlers constantly running, inserting into that database, and so we're going to hit that tier. And finally, the resource is ultimately returned to the user in the form of a web page, a Flash object, a Flickr set. I tend to talk kind of fast, so I'm going to try to slow it down. But if you have questions, please raise your hand and just ask, because I would much rather address questions now than to find out you didn't understand something early on. So, problems with traditional apps, and I totally stole this from Adaptive Path. But classic web applications, we talked about that big internet cloud. It's expensive to go across that. It takes time. And unfortunately, a lot of these times are fixed. I mean, your bandwidth's fixed. The network latency is fixed. The size of the response is fixed. And so normally a user will interact with the device, interact with the web page, submit a form, and then you've got this big, long wait period where it sends, the server processes, finally gets it back. This is why, in the late 90s, web applications sucked, because they were very unresponsive. You'd click something and kind of get something back later, very unresponsive, completely unlike desktop applications. The prime example is MapQuest. Now, I'm not saying MapQuest sucks now. I kind of like them. But who here used MapQuest in like 98, 99, 2000? Yeah, you didn't really want to use it, did you? It was horrible, because you'd click a link saying, hey, I need to navigate a little to the left or a little to the right, and you'd have to click this little east-west border thing, and the whole image would jump over that far. It was not granular at all. On top of that, when you click this button, the entire page would have to refresh. It would go get the little paragraph at the top. It would go get the ads on the side. I mean, it would do a complete HTTP request across the internet cloud and pull the entire new page down. And the only thing that really changed is I wanted to move the image where I currently was. You did zoom. It would take a second and a half. So it was very stop and go. It's like city driving when you have a Porsche. It just upsets you, and you want to fix it. So the whole thing is we want to try to reduce this long wait, because these long pauses are very noticeable. I mean, think about Word, right? If Word waited a second every time you pressed a letter or every time you ran spell check, it would drive you crazy. Now, unless you happen to be running like a 2 gig of RAM machine, Word probably does this for you. And, I can't do anything about that. But in terms of web applications, we needed some mechanism of making them respond the way a traditional web application or a traditional desktop application would. And that key really revolves around reducing this long wait, because you need the application to be more responsive, more interactive. But of course, we're kind of crippled right out the gate. I mean, the request we make, hey MapQuest, hey Google Maps, zoom in, or go 5 degrees to the right or to the left. I mean, that's a fixed. It's an HTTP GET. It's got some headers and some cookies. I mean, that's a fixed size. The response it's going to push back to me in the terms of an image or a full HTML page, that's also fixed. The network and latency is fixed. How do we actually make, if it actually takes as long as we saw right here, if it actually takes this long to go there, propagate, and come back, how do we trick the user into making it seem more responsive? Well, this is exactly what AJAX does. And the way it does it, well, so what's AJAX? AJAX is really just an acronym for Asynchronous JavaScript and XML. It's a suite of technologies. The quick and easy definition of this is it's a way to extend JavaScript so that it can make HTTP transactions without the user having to do something. So in this case, we see the traditional web application. The only thing about the architecture has changed is right there in the logic layer. Now JavaScript can contact the server. It can make requests on your behalf. So what we can do is intercept a user's event. I click a button, I start typing in a text field. JavaScript can then send that HTTP request and give immediate feedback to the user. The application's still responsive. You can still click on links, navigate around, because this transaction's occurring in the background. It's not doing what we call a hard refresh. Eventually, the process on the server returns, and we present the page to the user. Again, stealing from adaptive path. Immediately after we give it input, we can get responses in the display over here. Meanwhile, the HTTP request still propagates there and comes back. We haven't reduced this cycle at all. It still takes this long, this big U shape here. That's still there. But by having this JavaScript that's being able to continue to operate on user events and operate, we think it looks good. The classic example of this is really Google Maps. Google Maps, the first time you used it, I'm sure you're like, my God, this is better than MapQuest. Because it was. You wanted to go to the right a little bit, you just clicked and dragged, and you were there immediately. What's happening with Google Maps is it's using AJAX, to make these HTTP requests in the background. So as soon as you start looking at, say, Atlanta, which is where I'm from, you zoom in, and already JavaScript is starting to fetch all of the images around where you're currently looking. It's also starting to fetch everything that's one zoom level down or one zoom level up. That way, if you click or move, it's already got that data cached. If you've got a slow connection or you've got a really, really fast hand, you can actually drag off the end of the world in Google Maps. Just click and start dragging like mad, and eventually you'll start hitting gray because you're moving faster than it's actually pulling down images for. So needless to say, the application is a lot more responsive. We find this enjoyable. Writely. Has everybody here ever heard of Writely.com? See a couple nodding heads. So Writely is a word processor written in AJAX, and it's actually really impressive. So especially when you look at it and you're seeing that the feedback and the response is similar to Word, and then you realize that it's actually doing spell checking, it's doing all of these kind of classic web app or classic word processor functions, and it's over the web, you're amazed. And it's all because of AJAX. So the crux of AJAX is this fun little thing called the XML HTTP request object. Essentially, you can send any HTTP method you'd like. I've got a little piece of JavaScript over here. Basically, you instantiate the object. You tell it, you give it a callback function. You say, hey, when you're done with this request, call process request change. And then you say, hey, do a GET request to some URL. And true is, it has to do with blocking versus non-blocking. When the response is done, we come back and we say, all right, if the request completed and the response code was 200, great. So this is how JavaScript can then, and it can actually go, in this example, req dot body. It can start actually accessing the contents of the response. Jeremiah just gave a really good talk about port scanning with JavaScript. I'm going to talk a little about port scanning with JavaScript too. The trick is that we don't use AJAX for it, which is kind of bad. It's good because we get around the security, some of the inherent security in AJAX, but it also means we can't look at the response. And obviously, Google Maps would be kind of useless, or Writely would be useless, if it can make a request but actually can't look at what it gets back from the server. Now, this is one of the interesting limitations of JavaScript that they put in for security purposes and then promptly wrote a hole to get around this. And JavaScript or AJAX is only allowed to contact the site it came from. So if you're looking at maps.google.com and there's some JavaScript that gets pulled down, that makes AJAX requests back to maps.google.com. If I said get URL is yahoo.com, JavaScript would actually fail on the client side. It won't let you make those requests to other domains. It won't even let you make a request to www.google.com. It also won't let you make a request to maps.google.com, port 443 or any other port. You actually have to go back to the host and port. And finally, HTTP, the requester object, can fetch everything. I can grab XML. Don't let the name fool you. I can grab things other than XML. I can grab HTML. I can grab raw text. I could grab in the Microsoft Atlas framework, which is their AJAX framework. They are actually pulling down new JavaScript, which they then proceed to execute. I can grab images, Flash, multimedia, and like I said, script. So what are these problems? So we've talked about JavaScript, but what are actually the issues here? Well, AJAX applications have a huge attack surface. They have a much larger attack surface than traditional applications, and we'll get into why that is. And when I talk about attack surface, I mean the inputs you have into the application. Consider CNN, for example. CNN's a really large site, on the order of a couple million of pages. But how many inputs does it have? Well, you've got a place where I can search news stories. You've got a place where I can insert a stock symbol to get information. You've got places where I can say, sign me up for these email alerts. So you can actually submit, here are some email keywords I'm interested in. Or you can actually say, all right, let me sign up. But really, if you look at all of CNN, it's only got about a dozen or so places that the user can actually give CNN input. That's the attack surface. I can try to SQL inject you through that, cross-site script, parameter manipulation, file disclosure. Those are really the crevices, little holes, that an attacker will try to get into your application. To relate it to a house, these are your doors and windows. These are where I try to break into your house to steal your stuff. And so you need to lock those down, obviously. There are several implementation issues with AJAX itself. Oh, I'm sorry. Yes, we're going to talk about that. That's what's known as a bridge. Yeah, we'll talk about that. And I'll tell you, it's actually kind of funny that it was a good restriction to have. And I also understand why it would make sense to have AJAX talk to other domains. And so they came up with this concept of bridging. And bridging is actually a very large problem, as I talk right here. The way they implemented doing bridging was tricky. Basically, what happens if I'm running, BillysBookstore.com, and I want my users to be able to access the Amazon.com web API so they can do author search or something. And I want to use AJAX to contact that. Well, we already said that AJAX, if it came from BillysBooks.com, can't talk to Amazon.com. So there's something that's called an AJAX bridge, which is basically a web service running on BillysBooks.com, which forwards all of my traffic to Amazon.com. It's an open proxy and has all of the problems that an open proxy has. There's also a lot of buzz around AJAX. This almost sounds kind of like a lame security issue, but seriously, the hype and the buzz around AJAX is causing immense security implications, just in terms of what it's doing to the knowledge base, the types of resources that you can get out there to learn about AJAX. They're really quite poor. So, the attack surface of an AJAX application. We started talking about this. In a traditional application, everything really existed on the server, with the exception of maybe some client-side validation that I was doing. Let's make sure that they didn't enter a bunch of letters for the zip code. All the application took place on the server side. And it's very funny how everything old is new again. We went from timeshare computers to personal computers, and now we use our personal computers basically as dumb terminals to talk back to a centralized server again.